Can we start?
Yeah, start please. Yeah.
Okay. I shared my screen already. Hey everyone, good evening.
Good evening.
Yeah. Nice meeting you all after a week time. I hope you would have gone through the lecture notes. I mean the slides what I passed to you. Let's start the week class. All good. So we started discussing descriptive statistics last week. We discussed all measures we use in descriptive statistics like mean, mode, median, variance, standard deviation, IQR. So these are a few parameters we use in descriptive statistics in order to understand the data. So I started my lecture last week with the population and sample. Population is all observation. Sample is a part of population, a subset of population. So I discuss with you all this. Then we move to, yeah, these are the homeworks you would have tried already. Yeah, we move to hypothesis and hypothesis test. Coming to hypothesis is your idea and it's what you are trying to determine. In the sense, it's a climb, it's your climb. So you have a question for which you are writing a climb and for which you are going to do some test, statistical test, in order to confirm or in order to ensure that your claim is correct or not. Okay, so we do hypothesis test with our data. So I explain you why we use statistical test in machine learning. So the exact answer is we use statistical test sometimes in our machine learning. Maybe when you want to explore your data, understand the futures, then it is better to go with the statistical test like a correlation analysis or something. And once you develop the model, machine learning model, when you want to compare your models, in case if you had used random forest algorithm, SVR and different algorithms, and if you want to compare the performance of these models, then you can use a statistical test. So comparing two groups or three groups, that comes under statistical test. So it is better to use statistical analysis along with your machine model development. So I explained all these things in the last week. Now let's move to the week, okay, the current week, the lecture. I start with the null hypothesis. Null hypothesis is a type of hypothesis that proposes there is no changes or no statistical significance exist between the observations. In the sense, in case if you have two groups of data, you are claiming that there is no change between groups. There is, in the sense, the mean of the first group and mean of the second group is same. There is no variance between the groups. That could be your claim. It is what called null hypothesis. So null hypothesis may be correct sometimes, may not be correct sometimes. We do not know. So that is the reason we are going for a statistical test in order to confirm whether our hypothesis is to be accepted or rejected. Okay. Null hypothesis in statistics states that there is no difference between groups and no relationship between variables. This is what I told you. All right. So I'm just giving you some examples here. Look at the first example I'm showing here. In case if you are measuring the height of plant, okay, when you use fertilizer, when you do not use fertilizer. Okay, so there are two options you have, two different data sets you have. One is plant height when no fertilizer is used. Another is plant height when fertilizer is used. So now you can claim there is no change between the groups, or you can say that even when we use fertilizer, there is no change in our height. So that could be your claim. Or you can say that yes, there is a change in height when we use fertilizer. So this is what you are going to claim. Okay. So another example. So this is how the research question would be: does fertilizer increase plant height or not? So accordingly, you will write the null hypothesis, and exclusive of that one or the alternate of that one is called alternative hypothesis. All right. So I'm giving another example here. Yeah, average salary of machine learning experts is different for male and female. In the sense, you are collecting the average salary of male and average salary of female. You have two groups. So you are claiming that there is no change between the groups. The average salaries of male and female are equal. So that's what called null hypothesis. So here, what we do is we write like this. We write the mu value of the male group and the mu of the female group both same. Okay, just sorry, just give me a minute. I will start my stylus. Sorry. So I can write my hypothesis, null hypothesis, as we use letter H naught to represent null hypothesis. So I say here null hypothesis is the mu of male equal to mu of female. I write like this. So this is what called hypothesis. So what would be the alternate hypothesis? That will be mu of male not equal to mu of female. So you will write like this. So what we do, you conduct some test. I will explain you what test is required for this one. So we conduct the test, and then finally we decide to retain the hypothesis, null hypothesis, or reject null hypothesis. So that's what we do. Okay. Another claim. Let's see here. People with the PhD in analytics earn more than people with the PhD in engineering. In the sense, you have two different groups. You are writing the PhD salary of salary of analytics PhD is less than or equal to engineering PhD. You can write like that, or you can write it is more than engineering PhD. So it is up to you to write the null hypothesis. Whatever you write in a null hypothesis, opposite to that one will be the alternate hypothesis. All right. So I'm just giving another example over here. Please, can you answer this question? Organization often make claims about customer behavior, product performance, and market outcomes. Okay, so this is a scenario. So in case if you want to write the hypothesis, how it would be? Any answer? Any answer? So I can write my hypothesis claim like there is no correlation between behavior and performance. So performance does not change even the behavior change. So that could be your claim. Okay. All right. So I'm just giving another example here. Does a new teaching method improve the student exam scores? For instance, when you are collecting the average mark of average mark of students who followed the traditional method, 72%. The average mark of the students who followed new method is 73%. It is your mu. Okay, that means your average mean. So now you can write your teaching hypothesis as, so is equal, mu1 equal to mu2, or mu1 is not equal to mu2. You can write like that. So there is no significant difference in exam scores between two teaching methods. You can write like that. Okay, so like that, I put few examples here for you to understand and for you to reply me back. If you could answer this question, I'll be happy. Anyone can answer this? Does a new medicine reduce recovery time? Standard medicine is 7 days. Recovery time is 7 days for standard medicine. Recovery time for new medicine is also 7 days. So your hypothesis, how it would be? Any answer?
Oh, sorry, I was talking and I was I was muted. Sorry. So there would be no difference between standard medicine and new medicine
Exactly. So you will write like
in the
mu1
recovery
equal
time.
to mu2. Yeah, that's it.
Yeah.
So the new medicine has no significant effect on recovery time compared to standard medicine. That's what you will write. Right. The next thing, next question over there is, does lunar phase affect possum activity? So you have some data like new moon day, the number of activities registered is 12. Number of activities registered on full moon day 11. Number of activities registered on last quarter is 13. So there are different values over there. So you can claim lunar phase affect possum activity, yes or no. Okay, you can say that there is no significant difference. What I'm telling is that when you are collecting a group of data, when you take the average and you can see that the variance is very limited, very minimal, or there is no significant change in the variance. So it could be possible when you are going for a large data set. Okay, when you are taking a small amount, there could be easily you can visualize the changes, but when you are going with the large data set, you can see that there is no significant change. All good. So I just give you a task over here. You can do it at your home later. You can write any two research question and hypothesis related to your work or job. So for your own task, you write anything. Okay, and you can share with me, and maybe you can send me a message in WhatsApp or Teams later. All good. So moving on to statistical test, I told you already. Why we do statistical test is to confirm whether to retain the hypothesis, null hypothesis, or reject null hypothesis. That is the objective of our testing. That is our objective of the testing. So we need to do some test analysis. There are many different test analysis like G test, T test, chi-square test, F test, ANOVA, correlation. So there are various statistical tests available. So you have to choose the right method based on your research question and the data that you have. So you have to decide it first. And also you have to decide your statistical significance. That means what level of confidence you want to do your test. Is it 99% or 95% or 90%? What level of confidence you are going to consider in your test? So these are the few things you should remember. So I just listed here the steps we followed in determining the statistical significance. All right. So I will explain you I have a picture for it. I will explain you all these things. Choosing the right test. So how do we choose the right test? So actually in the data analysis, you can classify data analysis into exploratory data analysis or confirmatory data analysis. That means EDA, CDA. EDA refers to you are trying to understand the data before you start the model. So that is what called EDA. That means you'll be trying to find out the correlation between the variables. Correlation between the variables or correlation between the independent variables and the target variable. Okay, response variable. So that is what called the EDA process. Whereas confirmatory analysis, data analysis is the test you will do to validate your hypothesis, to confirm your hypothesis. That is what called the CDA process. So for which, how do we choose is, we decide based on what we want to do. Do you want to compare groups, or do you want to relate the variables, or do you want to predict the target? What do you want to do? So based on our task, our aim, our objective, we design the test. Okay. So all you need to do is, first you write your question, then you see what's our outcome data type. So how many groups we have? All groups, independent groups or paired groups. So independent groups are different. Paired groups is different. For instance, you're you're running a supermarket. Let us take. Okay, you are running a supermarket in two different locations, in Auckland and Hamilton. So the sales, you want to do the analysis of the sales. So sales in Auckland will be different. It is a group. Sales in Hamilton is another group. So they are independent group. It is not paired group. So and you may be having some assumptions. So you just see that your assumptions are reasonable assumptions before you take up the test. Okay, so in case if you want to compare groups, you can go for t-test, ANOVA. Okay, if you want to study the relationship between variables, you go for correlation or chi-square. If you want to make predictions, you can go for regression models. All right. So key message here is, the test is selected after understanding the research design. Your research design is important. Your test design is important. Okay. Is there any doubt? Do you have any doubt? So far, okay? Okay. Can I proceed?
Yes.
Okay, fine. Thank you. So moving on to t-test. Let's discuss the test now. Okay. T-test, I told you already, the t-test is the one we do to compare groups. Okay. T-test uses means and variance. Okay. When you know mean of your sample, mean of your population, and variance or standard deviation of your sample, then you can go with the t-test. Okay. I repeat, when you know mean of sample, this symbol we use for mean of sample, right? Sample mean. And mu, this is population mean. And standard deviation, okay, yes, of sample standard deviation. Okay, so when you do not know the standard deviation of population, so when you do not know this, you know only these three parameters, you can go for t-test. Okay, so this t-test is used when the population standard deviation is unknown. Okay, so it is what explained. There are many different types of t-test. One sample t-test, independent sample t-test, paired sample t-test. So we have different groups, different methods. So we use one group to compare with a benchmark. That means if you have only one group of data, you go with this one sample t-test. If you have two groups, as I told you, you want to analyze the sales in Auckland as well as in Hamilton. You want to compare it. Then you can go for two separate groups you can go for independent sample t-test. And when you have the same people but measured two times, that means you want to confirm, validate your predictions, or you validate your test analysis. So what you are doing is, you are collecting the data in Auckland itself, the first day and second day, okay, or first month and second month. So you are working with the same people or same items but measured 2 times. Then you can go for paired sample t-test. All right. So I just give here example for one sample. I put an example here. Is average delivery time different from 30 minutes? 30 minutes is the average delivery time, but is there any difference? Is in the sense, if the average delivery time is greater than 30 minutes or less than 30 minutes. So that is the thing you want to check. So your hypothesis here can be greater than average, can be average delivery time mu is greater than 30. Alternate is this is greater than or equal to is less than 30. So you can write like this. Okay. So this is your null hypothesis. This is your alternate hypothesis. Then you can go for t-test and confirm your result. Let me start. Just a moment. Then independent sample t-test. Do training methods produce different test scores? That means you have 2 different training methods. Okay, you want to compare whether there is a change between these 2 training methods. That is what called independent sample t-test. And paired sample, did productivity improve before and after software training? That means you want to check before and after, but with the same item, same people or same people. That's what called paired sample t-test. So you may have some assumption and conditions in the t-test. Okay, I listed here. All you need to see is you should know is continuous outcome. That means your t-test is going to compare means. So you should have continuous outcome, continuous data. Maybe 30 data, 100 data, 1000 data. Some data you should have continuous data over the period. Then you can go and find out the means of your data set. Okay, so these are some conditions you should know, you should do before you start up your testing. Straight away, I move on to explaining you one sample t-test. So this is the formula we are going to use to calculate t-calculate. Let me explain you very clearly the procedure what we follow. Very simple. What we do is always we suppose if you have data, okay, if you have some data for many days or many observations, okay, if you have many observations, then you will find out sample mean and population mean, then sample standard deviation. So you have to find out these 3 parameters and use these parameters in this formula to calculate t-calculate. So you will find out t-calculate. Once you know t-calculate, then you will refer the table. Ready table is available for t-test. It is what called t-significance table. So you will refer the table and find out t-critical. Okay, so this t-critical we find based on our confidence level alpha. So confidence level alpha can be 99%, 95% or 90%, up to you. Suppose if you are using alpha equal to 0.99, your p-value is 0.01. That is your p-value. If you are using confidence level 95%, your p will be 0.05. Okay, so this is your p-value. So what do you do is you find out t-calculate and t-critical. Initially, when you are fixing your hypothesis, that's more important, your hypothesis, how it is. Suppose if you are saying that your mu is, for instance, I'm telling equal to 2000, you are writing like this. Your HA is mu is not equal to 2000. If you are writing hypothesis like this, so if you are using equal to symbol in hypothesis, it is what called two-tail test. It is what called two-tail test. That means you'll be having the rejection on both sides. On both sides. So this is your accept area. This is your reject area, and this is also your reject area. I'm going to show you examples. Okay, I'm just explaining the theory background. So what you do is, once you calculate the critical value, so critical value is here. Your critical value is here. Critical value is here. So once you calculate with this formula, once you calculate the T calculated, you see that T calculated is less than this or within this area. If this calculated value within this area, then it says that your hypothesis is accepted, is retained. That means there is no significant change. So your hypothesis must be retained. If your T calculated is greater than the critical, if it goes here or here, you will say that it should not be retained. Your null hypothesis must be rejected. So this is the decision making. Okay to you? Are getting me?
One question. How do we know T critical?
Yeah, that's what I said. You have to refer a table called T-test significance table. It is readily available table there, statistics table. So you will just refer the table and find out this critical value according to your degrees of freedom, according to some parameters. Okay. So this is the procedure when you are referring statistical table. In Excel, we have the formula. So if Excel will find out T critical for you, will calculate T calculate also, it will find out for you. So if you are using tools, it is very simple, straightforward. Okay to you?
Yeah, okay, thank you.
I'm going to explain all this once again. Okay. We have two methods to take the decision. One is using the p-value, another is using the critical value. I explained you critical value already. Okay, so this is what I told you. You can use Excel or R program or Python, SPSS, Jamovi, all this to calculate p-value or your critical value. So you can use straight away, you can get it from your software. One. Otherwise, you have to use the T distribution table. It is a statistical table available. So you have to use T distribution table and calculate your T value, critical value, based on your degrees of freedom, based on your data. All good. So another approach, in case if you want to use the p-value approach is another way. Okay, so you can use critical value approach. I told you T calculated, if T calculated is greater than T critical, you reject it. You don't accept your H naught. That's what I told you. So another method is p-value method. So you know that p-value can be 0.05. This can be maximum 0.05 when you are considering 95%. Okay. So what you can do is you can compute p-value from your t-test. You can get the p-value from your t-test, and if the p-value is less than or equal to this 0.05, okay, you will reject your hypothesis. You will say that there is a significant changes. What you assumed is not correct. Okay, so this is another option we have. All good. So I suggest you to follow either one method. You can follow critical value approach or p-value approach. Any one is enough. So I put here everything in the slide, in the graphic form. Okay. So what you do is, this one I'm showing here. This is the reject area. This is accept area, like this. So you have reject area, accept area. So the first one I'm showing here is right-tailed test. This one is left-tailed test. This one is the two-tailed test. So what does it mean is two-tailed test is the mostly we use when you write equal to symbol, equal to. So when you have less than symbol in null hypothesis, you will go for left-tailed. If you have greater than symbol in the null hypothesis, you will go for left-tailed. So that's difference. That's the difference. So it all depends on how you are writing your null hypothesis. Are you writing like this, less than 2000, or are you writing greater than 2000, or are you writing equal to 2000? Depends. If you are using this symbol, less than symbol, you will go for right-tailed. If you are using this symbol, you will go for left-tailed. If you are using equal to, then you will go for two-tailed test. So these test data, I mean the tables are available. You can Google and get it, or there are some manuals or books having all these tables. You can use it. Otherwise, just use Excel. Excel will give you everything. Okay. It's not showing. Okay. When once your test is done, you will report it. Very important thing, you have to report your t calculated value and p calculated value, and you have to give an interpretation, conclusion, whether you are accepting, you are retaining your hypothesis or not retaining your hypothesis. You have to say this one. That's more important. So your answer is very important. You have to write like this, what test you did and how did you interpret your result. I think there is a problem with my, yeah, I think there is a problem in my slides. Let me close it.
Maybe save as if you want to change.
Yeah, let me check.
Already you closed, right? Okay.
No, I think
Picture can't be displayed.
it has to
Maybe
be repaired
moved.
because I recently I made a change. That's why.
Mhm. Maybe keyboard.
It's okay.
Mhm.
Yeah, now okay, I think. Okay, I give you a home task. Okay, you can do this one. You look at there, the scenario over here. The Department of Civil Aviation reports the average flight delay is 16.8 minutes. A sample of 50 flights has mean value 19.5 and standard deviation 6.6 minutes. Test whether the average delay is different from 16.8 minutes. So everything is given to you. Okay. So you have to write your hypothesis like this. You can say that your mean value is 16.8. That is your claim. Average flight delay is 16.8. You can alternately write no, there is a change. Okay. And you have the x bar value and standard deviation, which you can use in the formula, this formula, to find out test statistic. And since you used equal to symbol here, it is two-tailed test. So for two-tailed test, you can get the actual critical value, then you can compare. So you can do this one in Excel. Okay, not necessary to do the manual calculation. In case if you can do it, perfectly okay for me. Otherwise, you can use the Excel to do it, or you can use Python script to do it. Okay, this is one sample t-test. I'm moving on to the answer also there. You can see the answer later after you completed your test. Then moving to next. In in case if you have two groups, you can go for independent t-test. Okay. In case if you have many groups, 3 groups, 4 groups, then how do we do? So there ANOVA comes in. So instead of t-test, because in the t-test, if you have 2 groups, you can compare it. When you have third group, then there are other possibilities. For instance, if you have 3 groups of data, let me show you. Okay, 3 groups of data. Then you have to compare these two. Then you can compare these two. Then you can compare these two. So how many times you have to do? So you will repeat your t-test with only 2 groups. That's not correct way, or it is time consuming otherwise. So it is better to go with ANOVA, which is the better statistical analysis tool to compare many groups. That in the sense 3 or more groups. Okay. So before I continue with this, I just to take you to Excel. I shared with you the data files already. If you open my XLS t-test training method, yeah, I put sample data here for your practice. For one sample t-test, you have to do manual calculation, either manual calculation or you can use the Excel function to get the answer. Okay. The next one is independent t-test. For independent t-test, I already told you, when you have 2 different groups and you want to see whether there is any change between groups. Okay. 2 separate groups there. They are receiving 2 different training methods. You want to test the mean score difference there or not. So for this one, what you can do is you can use data in Excel, data analysis. In data analysis, you just take t-test, okay, t-test, and you are doing independent t-test, the second one and third one, either second or third. The second is for the equal variance, third is for unequal variance. So what you do is you just initially you find out the variance in the first group and variance in the second group. For example, I put value over here. The variance in the first group is 2.7. The variance in the second group is 2.06. That means it is not equal. It is unequal variance. When it is unequal variance, you go with this test. Okay, well test. So this test, so what you do is you go to data, you go to data analysis, select T unequal variance, this option. Select this option, say OK. Then you have to say the range, the first group, then the second group, say the range. Then you set your alpha. This I already told you, alpha is confidence level. It could be 99, 95, 90 or anything, up to you. So you can assume it. Suppose if you're considering 95, you put 0.05. Then where do you want to get the result? You want to get the result in the same sheet or new worksheet or new workbook. You decide it. Then you press OK. So you will get the answer. That's it. Simple way. No need to do any manual calculation or no need to refer the statistical table at all. You can get it. So if you look at this one, this is very important to interpret. You have to interpret this result. Say, for instance, the mean value between the groups there, variance between the groups there, number of observation in each group there, then degrees of freedom is 20, and T statistics. That means this is the one you calculated. Okay. And you, based on your hypothesis, for instance, if you are assuming that both mean same, okay, if you are assuming both mean same, mu1 equal to mu2, okay, that is your hypothesis. Your H0 is mu1 not equal to mu2. Then you will go with the two-tailed, okay, two-tailed test. Now you calculated the statistical value minus 7.05. What is the critical value for this one? The critical value is 2.08. That means 2.08 is the maximum value that you can have. You can consider minus 2.859 on the left side. So this is on the right, it is positive, on the left, negative. You look at your answer is minus 7.05, minus 7.05 somewhere here. The sense it is going in the rejection region. So this is reject region. This is also reject region. This is the only accept region. So that means since your value is very smaller than your critical value, you will not retain your hypothesis. So what you assumed is not correct. So there is some changes between the groups. So that is what you will interpret to your management. Am I okay? Am I okay? Are you getting me?
Yeah,
Okay.
much clear.
Much clear. Okay. So if you want me to repeat, let me know so that I will give you another example and repeat it once again. All right. So this is the way you do independent test. So I erase it. I go with the next one, the paired t-test. I already told you for the paired t-test, in case if you are working with the same item or same people but observing 2 different times, then you go with paired one. That means it has before data, after data. Okay, so before data, after data. Look at the paired the scenario given here. The same employee are measured before and after training. The test whether productivity is changed or not. The alpha value you can consider 0.05. You can go with the two-tailed test. That means you are assuming that there is no change before and after. Both same. That is your assumption. So your alternate hypothesis says it is not same. So again, coming to this one, you are going for two-tailed test. So you will have the reject region. Okay, so this is your T critical value, positive. This is your T critical value, negative. Okay, so what we do is we just go with the data analysis. Then we take paired to sample this option. We select it. We have to say the first range, then second range. Then we have to set the alpha value here and also the hypothesis mean difference. Hypothesis mean difference is you can find out, that is a mean difference you can find out. Okay, so I already calculated and put here. So you can set up these things, then say okay, you will get the answer. So look at the answer over there. It says mean of first group is 51, mean of second group is 55.66. The variance of first group here, variance of second group here, observation in the first group, observation in the second group. Okay, Pearson correlation, I will come to that one later because we have other slide to explain the correlation. Then this is the one you measured, statistics value. So as I told you here, paired t-test, your critical two-tail value is 2.2009. 2.2009. This is the one critical, 2.0009. This is minus 2.009. What is the value you have got? It is minus 47.49. Minus 47. Where is minus 47? Somewhere here. Somewhere here in the reject region. So in the sense, what you will interpret finally, decision is I will not retain null hypothesis. I find there is a significant change between the groups. Okay to you? Everyone got me? Can I close this? All okay?
Yeah.
Good. Let me move back to the class. All right. So coming to ANOVA. ANOVA is the one better for when you have more than three groups, or three or more than three groups. Okay. I told you already how comparisons, pairwise comparisons we do. When you have three groups, you need to do three comparisons. When you have four groups, ultimately you will have six comparisons. You just think of it. When you have four groups, you can compare these two. You can compare these two. You can compare these two. You can compare with this. You can compare with this. So there are continuous, no? You can compare this, you can compare this and this. Six possibilities will be there. So working with the six combinations, pairwise combinations with t-test is not good, time consuming. So the better you go with ANOVA. All right. What we do is ANOVA, I'm just showing here full ANOVA, full model. Okay, full model. For instance, if you have three groups, three different groups, group A, group B, group C, you will find out mean for each group mean, mu1, mu2, mu3. And also you will find out the total overall mean. You will find out overall mean. Then you will start comparing them. You will try to find out the error between mean, error between this group and overall mean, this group and overall mean, this group and overall mean. And also you will find out error within the group, error within the group, error between the group. So you will do two different things here. Okay, so what you do is just simple thing I will explain you. I'm just showing here on the right the detergent sales by discount level. So the company selling detergent, they are giving discount 0%, 10%, 20%. Okay, in Auckland, one company giving discount, three different discount, and the sales is recorded on 0%, 10%, 20%. So you have three groups. So how many observation you have in each group? 1, 2, 3, 4, 5. 5 observation there. How many total observation? 15 observations there. So your number of groups 3, right? So you will use k equal to 3. Total observation is 15, right? So n equal to 15. Okay. So this is how you are going to work with. You will find mean for the first group x1, mean for the second group x2, okay, x bar 2 or mu2, third group x bar 3. So you will find out all this mean. Then after finding this, you will find out overall mean. So you will calculate group mean, overall mean. Then with this one, the formula I have placed the formula here. The answer also here. You can go through it later. Okay. After finding the mean, then you will find out the variation between groups. So this is the formula you will be using to find out variation between groups. Okay, so that is what called SSB. SSB. So it's referring to variation between groups. Then you will find out variation within the group, SSW. Then with these two terms, SSB and SSW, you can find out total variations, SST. So in each slide, I used calculators to find out the answer. I put answer also for the same data. Okay, I'm just explaining the procedure. So ultimately, you are finding total variation among the groups. Then after you find it, you will go with this formula to find out mean variation between the groups, mean square error within the group, mean square error between the groups, mean square error within the group. So that gives you the F coefficient. So you are finding F statistics. So they same decision making formula. So once you find out this F statistics, you see that F is greater than your allowable, your critical or not. If it is greater than critical, you will reject. If it is within critical, you will accept. That's it. This is the decision making. Okay. So you will do you will take the decision based on your F value. So if F calculated is greater than critical, you will reject. Right? I just put the data, all data and the results, everything here, and also the conclusion, I mean the interpretation of the results as well. So all you need to do in ANOVA is to understand F critical value and P critical value. F value, P value, both. Okay, it all depends on the number of parameters you have. Okay, I'm saying only we are working with one factor. The same way you can work with the two factors. I give you a simple example. You have a detergent. Okay, you are selling in Auckland, giving discount, 3 different discounts, 0, 10, 20. So you are doing this analysis for this data, and the same thing you have in other branch. So that brings in another factor, second branch. So in case if you have two factors, then you will go for two factor ANOVA. So it is the one I explained you is one factor ANOVA. Okay, so I just put all worked out example here to understand how it is to be done. Okay, so the ANOVA complete flow is here. Okay, what we need to do, everything there. Right. So I have a home task also for you. Okay, you can work with this home task. I will explain you how to do it in Excel. Okay, so what you do is you just go back and check my Excel sheet. Okay, this one way ANOVA training method. Just start it. You see, I put method A, method B, method C, all data observations there. So what we do is we just go data analysis, then we choose ANOVA. I'm working with ANOVA single factor. So the instruction also I added here. Okay, single factor, you choose it, then you select the data that you want to work with. Okay, then you say group with the columns. Okay, because you put everything in columns, group with the column, and alpha value 0.05. It depends on you. So you say okay. Once you said, you will get the total answer, I mean complete answer on the screen, right? So this says the F value. Look at here. F value is 25. For our data, this F value is 25. Actually, what is the critical value? It is 3.28. So this is your value. So your F value, calculated value, is greater than F critical. So in the sense, for this data, I don't accept my H0. I will reject it. That's the answer. So when you look at here, you can see all this. This is the value SSB between groups. This is the value SSW. Okay. So this SSW, SSB, all this you can calculate using formulas. Okay. So this is your MSB. This is your MSW. So with this MSB and MSW, F is calculated. That's it. Okay. Did I reach you?
Yes.
Hello. Did I reach you? Okay to you? Should I repeat it?
Yes.
No need. Right? All okay, right? No need to repeat. I just to close it. I go back. Okay, I have a homework for you. You can practice it. Okay. So very important thing is, even if you work with t-test or ANOVA, that tells you there is some changes. There is some significant changes between the groups, but it doesn't tell you which group makes more difference. Okay, that's important. You should understand. So it says there is something change, but it doesn't say which group is more significant, more changes there, which group doesn't have the changes. So it doesn't tell you exact group. So if you want to find out which group is important or which group has more changes or significant increase, then you have to go for post hoc result, post hoc study. Okay, the post hoc study will do with the pairwise study. So it will work with like 10% versus 0%, 20 versus 0, 20 versus 10, like that. So that will give you the exact location, exact group where the difference is higher. So this kind of analysis, this is another test, post test, okay, post hoc test. So one of the post hoc test is Tukey HST. This is the test. So there is an option in Excel. You can try this one. Python also got this function. You can use that function to find out which group has more significant effect. You can find out. And accordingly, you can write your decision to management. So you can say that like this: discount levels affect sales quantity. However, profitability should also be considered before choosing 20%, because we find that 20% has significant effect. So you can write to your management that 20% has more effect, but however, the profitability should be considered before choosing 20%. All good. Coming to the relationship, in case if you want to check the relationship between the variables, futures, then you go for correlation analysis. Okay, so correlation analysis is otherwise called Pearson correlation. There could be some linear relationship between variables. That means if one variable increases, another will also increase, or one variable decreases, other one will decrease. Otherwise, one increases, other one decreases. So there could be any relationship. So that you want to find out with the correlation analysis, Pearson correlation analysis. But when you look, all you need to do is, once you get the data, you plot the data into your scatter plot. When you plot them in the scatter plot, you can understand how the data goes, the trend goes. So if you look at this one, it goes up, it goes down. This is not in the linear way. It's randomly, almost little linear only, randomly distributed. So you can see the trend of your data with this one. That means it is positively correlated. This one is negatively correlated. That means it is decreasing. So all you need to do is, with your data, when you have data, you have to find the Pearson correlation coefficient. The Pearson coefficient will be within this range, -1 to +1. Okay, within this range. So if the signs showing, sometimes it may show positive sign, sometimes it will be negative sign. If it is positive sign, you can say that it has a positive strong correlation. If it has a negative sign, you can say that it has a strong negative correlation. If there is 0, that means you can say there is no association between the variables. Very important thing I should tell you here, the correlation analysis gives you the association. It doesn't give you the cause. That's a very important thing. Okay, because when you are working with the correlation, you are finding the association, not the causal relationship. That means there could be another variable playing into this game to increase a variable or decrease a variable according to the other one. So we do not know. So there are some possibilities here because of the coincidence or confounding or some errors. There could be the change between the variables. One increases according to the other one. So it is, you are just checking the association. You are not checking the causal relationship. That is very important thing you should note down in analysis. Okay. So as I told you, once you get the data, you just go with the scatter plot and see that how it varies. and you find out R measure. Okay, so sometimes you may have the curved relationship. Sometimes it will be a line relationship, linear relationship. Sometimes it could be a curved one. Doesn't matter. So I'm showing an example here. So this is the formula we'll be using to find out R. Okay, so we will work with X bar, sigma of first group, Y bar, and sigma of second group. Okay, accordingly we check our second variable, first variable. Okay, we work with. Okay, so this is the formula, R value formula, but in Excel you can use CORREL function to get it. Python you can use CORR. I will show you how you can work with Excel. Just go to my Excel sheet, correlation training methods. Okay, so I have two things here. So I'm just checking. I have 12 observations here. Want to check whether study hours correlated to test score or not. So 2 hours studying, 50 marks scored. 3 hours study, 60 marks scored. So I want to see the association between these two variables. So what I do is I just go with the data, then data analysis, then I choose correlation. Okay, I just choose the variable, the range, then I say okay, then I will get the answer. So my answer says there is association between two variables, study and the marks scored. So number of hours and marks scored have some correlation with the coefficient 0.919. That means it is strongly correlated, strong positive correlation there between these two. That's what you will say. Okay to you? Okay? Any doubt?
All good.
All good. Okay. So I go with the next one. So I have in-class activity here. You can try this. I put the hours test score. Okay. You just to use scatter plot first, then you calculate R manually, and then you can verify it in Excel. So formula also given here. I put answer also here. Okay. So answer also there. You can compare it in case if you want. Okay, so now it's a time for you to tell me the answer. Which test would you choose? Read the question and tell me. A teacher compares exam marks before and after a workshop. What test you will go? You will choose. You have two groups, but it is all of the same set of students or set of item. You are checking before and after.
T-test.
Paired t-test. Paired t-test. Okay. So the thing is you are working with same item but before and after. So paired t-test. The next is a lecturer predicts final score using attendance and assignment marks. You are using two different variables here, attendance and assignment mark, and predicting the final score based on that. So in the sense you are working with the past data. So with the past data, you'll be able to get the regression equation. Once you get a regression equation, when you substitute the new data, it will predict the final score. Okay, but here we are using two factors, two features. So it is what called multiple linear regression. It is what called multiple linear regression. I didn't include regression method here. because we are going to see the regression model in prediction model development. So when I teach you the prediction model, I will explain this as well, the single linear regression and the multiple linear regression. That's why I avoided, because I do not know how good you will accept when I teach statistical analysis, because there are plenty of things we can learn for analysis. So that's the reason I just restricted myself, explaining you only t-test, ANOVA, correlation, only these three. Okay, the conclusion is, when you get the data, please, you see the data first, you check the data completely. Okay, you follow the workflow, then you choose the right analysis method, then you do testing to understand your data, because good analysis turns raw data into defensible decisions. So if you do not follow this way, then your decision may not be right, or it may not be defensible. All good. So there, the week 2 slides complete. So if you have any doubt, you can ask me. Then I'll start week 3 one. Okay, I will give you few things in week 3, so that we can continue with the week 3 slides, the Python codings from the next week. Okay, so please, if you have a doubt, you can ask me now. I just conclude what I taught you last 2 weeks of time. I started with the data and the procedure for data analysis, the different types of data, and I started explaining you statistical test, why we should do, where we do, and a few examples. So I gave you the exercise as well for your practice. Now if you have any doubt, you can ask me.
I would probably have questions, but I would like to go through it first, again on my own, and just actually do some of the testing, like the examples you've done, and then actually do it myself. And then if I don't understand, I can ask questions if it's possible.
Okay, all good.
Okay, thank you.
Thank you. So if no more question, we just close this slide. Okay, let's move on to the next. The week 3 slides. I will share with you this week 3 slides, okay, tonight, so that you can refer it. And when you come to the next class, you will know many things, because this is the fundamental of Python codings. Let me start it. Okay. All right. Friends, so far I just gave you some fundamentals. Now I'm moving to coding. Okay. For the next few weeks of time, I'll be discussing with you the basic commands in Python. Okay. I will discuss with you how to input values, how to print values, okay, how to use variables, okay, what are the different data types we have in Python, and how to control our structure. I mean, take the decisions, if statement, loop statements, and how to write functions. All preliminary basic things I will cover in 2 weeks of time. Okay. Then I will move to NumPy. NumPy is a library. It is a library. It's separate from Python package. Okay, it's separate. But NumPy is a very good library which has many functions for handling arrays. So that is very much important to you. Okay, because what you do is, once you get the data, the raw data from your source, you will convert them to arrays. So it's a kind of thing we do always. So NumPy is very important. So I will explain you NumPy, teach you NumPy functions, and then I will take you to plotting. Plotting, because our objective of this class is to give you exploratory data analysis, right? So I should explain you how to plot your data, like how to create scatter plot, how to create bar chart, pie chart? When do we use bar chart? When do we use pie chart? When do we use histogram? So you should know when, how, why. So you should be able to answer these questions with your data. So that I will teach you with plotting. It's matplotlib. That's that library I'm going to discuss with you. And finally, I'll be discussing with you pandas. Pandas is it's a way. What I'm going to tell you is, in case if you get some raw data from the source, how you can create a data frame and how you can do some descriptive analysis with that one. The basic EDA process I will explain you. There our course will be end. So there our course will end, and so I will take next 4 weeks of time to complete all these things. Okay, so this is our idea. Okay, all good. So this is what I explained in this slide. So what I'm going to teach you, the learning outcomes. Okay, maybe this end of this week, I said end of this week is itself you will be able to write Python programs, work with arrays. Of course, it's slight delay over there because of I couldn't complete everything last week. So next week, sure, you will be able to write some Python codings. Okay, so learning, this is the learning flow I'm going to follow. I already explained you everything. Okay. Coming to Python, why do we need Python? And what level Python will help us? Okay. Of course, it is a high level programming language like C or Java or anything, C++ or anything, but it is very robust programming language. Okay, it is very easy, very clear. It has got plenty of library functions. Very important thing is it's open source. That's the reason you could use any sort of libraries. Okay, and also it's extended. Libraries are extended as well. So we can do plenty of operations with Python. You can do data analysis, you can do image processing, you can do anything with this Python codings. Okay, what do we need for Python? You need some interpreter to work with the Python. So what are the options we have? What you do is you can go to python.org and download the interpreter. You can download the package. Okay, that's the first option. You can download Jupyter and you can work with that. Or otherwise, you can use some third-party interpreter like JetBrains. JetBrains got PyCharm, so you can download PyCharm from JetBrains, and you can, it's an IDE window, I mean integrated development environment, where you can create the script and can store it. So option 2. Option 3, you can easily work in Google Colab, that is online one, and also the data is stored in cloud. Whatever the script you are developing, all scripts will be stored in your Google account. Okay, so Google Drive. So that's a third option you have. So in case, but the important thing is there could be some changes in the functions. Okay, not all functions similar in all environment. Like when you are working with the PyCharm and Google Colab, slight change would be there. Okay, please, that small adjustment you have to do, but it's an option. Or can work with online and store it in the cloud. The final option, but not a good option, is online interpreter. That means you can just work in online, not necessary to use anything, download anything in your computer and use it. Okay, so I said 4 different options. I will just tell you the 4th option here. You can Google Python online interpreter. Okay, so just you Google it, you will get some third party website. You click it. Just a moment, taking a moment. Okay, if it takes a moment, I'll go with the other one. Yeah, very simple. So I can type here and get the result here. It's a third party one, but it is not good to use this one. Maybe it is okay for kids, but for adults, it's not good because we should have our own code for future use. So I don't prefer this option. Okay, first one. The second one, you can go with JetBrains, sorry, Google Colab. I'll explain you Google Colab. So Google Colab, just use your account, any Google account. Okay, so I just use my Google account. All right, so I got it. So I can open my notebook or I can work with the new notebook. Okay, I can key in everything. Say these are the files already created. Maybe I just open it and show you how it is. Yeah, that's it. So I can just use this coding there. I can run it and I can get the answer. Okay, so everything is stored in, but it is keeping your program only during that runtime. Once you quit it or once the runtime is interpreted, your code will not be here. It will be in cloud. You can open it later. Okay, everything is stored in cloud time to time. So you no need to worry. So just you work, you close, then you open it again next day and work. So this is second option you have. Then third option is you can go to JetBrains. Okay, it's a third party. So this JetBrains you can use to download your IDE. So you can choose your IDE, PyCharm, and download it. Okay, I download it already. I'll show you. Since I'm using Mac, I'm just going to applications and use it. But if you are using Windows, you can have it somewhere here, your icon. Yeah, PyCharm 2026 one. So got it. So easy, very simple. I can just use new script and I can type whatever I want. I can type. That's it. Then I run this one. I store it, I run it, or I run it. Maybe if I don't want, I need not store it. Okay. So this is the fourth option we have. All right. Everyone got me? So now I leave to you how you want to work with. Okay, it is your preference, but see that you have some Python interpreter with you from next week onwards, because then and there, when I teach you all the commands and everything, we can work together so that you can try in the class itself. And in case if you get any error, you can chat with me, you can ask me doubts. All right. So the IDLE, how it works. So same thing with the other language. So you can open IDLE like PyCharm. You can use new file or new script. You can type your code. You can store your code in with the extension of .py, a Python code, and you can run it using F5. Then you can get the answer in the shell. Okay, so like this, you can type and you can get the answer there. Okay. So now you can practice this one. In case if you have Python interpreter, you can practice, you can type like you go to PyCharm, you can just use hash. So this is my first program. Okay. Python code. So I want to print, okay, I want to print my first Python script. Okay, so that's it. So I just type, then run. I get the answer in shell. You can see my shell got it, my first Python script. So I can add any number of lines. Maybe I can put another print. I'm Ilango, living in Central Auckland. So next line, I get it. Yeah, my first Python script, I'm Ilango, living in Central Auckland. So this is how you will be working with PyCharm. Okay. Next, Python got syntax and the data types. When you are writing Python, it is very important for you to follow some format. Okay. In case if you know C language, you know that we use flow braces. Like what we do is we write main bracket open bracket like this, right? So this is the flow braces we use to make a block, but Python doesn't have this kind of things. So it uses intent. Okay, indentation is very important. So that's what you should know, the syntax, how the Python code is to be written, and what are the data types we use. So Python uses indentation to mark blocks of code. So it is very important when you are using, so for instance, I'm telling if statement, we leave some spaces here. So when you leave some spaces, when you write if x is greater than 10, print x. So if you write it, so this, you can write any number of lines, okay, doesn't matter. So all these lines, a block is considered to be executed when this condition is true. So that is how it is going to work. So when you have another option, you can write else colon, then you can write another block here. So this option, when the condition is false, this block will be executed. That is how it will work. So your lines and indentation is very much important as far as Python is concerned. Okay. And you will write hash symbol to write the comments. Okay. You can write single comment line using hash. You can use 3 apostrophe. You look at there, 3 apostrophe I use here. Okay. Then I can write multiple lines. Then end with the 3 apostrophes. So this is multi-line comments. Single line comment, multi-line comments. Okay. So I stop the class here. That's all for the day. We continue with these slides, the Python codings from the next week onwards. Okay. All what I said today is, please download your one of the interpreters into your laptop. Okay, and try to write a small code, 2 lines code, what I written, print something, then you try it. You can use hash to write single line comment. Okay. Is there anything you want to ask me? So I stop here. We will continue it next week.
You are all following, and please utilize Elango because he's an expert, and I hope you are all understanding and trying the examples and the homework that he's giving. He's a very good resource, so please utilize these classes and bring all your questions to the next class. And also, whoever is not in the WhatsApp group, I'm just sending you the link to join the WhatsApp group because we are tending to put more updates there rather than sending emails.
Okay, so I just want to share something. So what I have observed in this class today is it's too quite not interacting. People are not interacting. They're not
Except for
whether
Monique.
yeah, whether good
Yeah,
or bad.
last
Let's try to answer because he's putting so much effort and putting the things together. So it would be a great sharing the knowledge with each other. If someone of you have asked any one question, then might be the other person thinks the same way, so we don't know what's going on. So just please be more interactive. That will help everyone in the class.
Yeah, absolutely. I agree with you, because when you ask question, yeah, teacher will like to answer more and take the class in
That's
the
why.
different way.
Yeah, and it will be
And
quite
everyone will learn.
interesting. Yeah,
It's last 2 class was absolutely good, but
yeah.
today everyone quite
Today
became maybe
maybe
tired.
yeah.
Maybe tired.
Yeah.
I don't know. It's
So,
okay. All good.
yeah. All good, all good.
Yeah.
Yeah.
Okay. Thank you,
Okay, I
everyone.
think,
See
yeah.
you
Thank you,
next
everyone.
week.
Yes.
Thank you.
Okay.
Thank you so much.